Hi, welcome to APchemistrycourse, and today's lesson I'm going to talk about Avogadros law. Alright, let's talk about the backstory of Avogadros law to understand what's happening. So, let's imagine we have a container. Alright, we have a container that has no rooftop. And we have a slidable roof inside it. And there's an opening for gas to enter inside. Alright. And we have another opening that can let gas out with a valve in it. So, let's say now we close the valve in here and we start opening the valve on the right and letting air go inside. After a while, we can notice that the slidable rooftop will go up. So starting from this point, as we increase more gas particles inside, we notice that the rooftop reaches this side, here. So we notice that the roof is going up. How's that? Or how's that? So then we want to test our experiment and understand what's happening. We open the valve here, we close the valve of the air, and we open the valve right over here, and we start letting air going out. The air will go out, no more air inside. There's less amount of air. So we can notice then what happened next. Surprisingly, the rooftop went back to its normal level after letting the air out. So, what's happening right over here? Did you notice that as we increased air, the volume increased? Because we noticed that when we added more air inside the capsule or the container, well, we saw that the slide or the rooftop is increasing its volume, so that it's going upwards rather than staying in its position. So we notice that first thing, there's no increase of pressure because we're just increasing the volume. So we can tell that there's a small relationship between the amount of particles we're putting in and the volume. Let's look at it. We can say as the number of particles increases, or we add more particles, then the volume must increase with it. Or if the volume increases, the number of particles must increase. And the opposite is also correct. Volume decreases, the number of particles decreases, or if the number of particles decreases, the volume would decrease. Now, can you guess what type of relationship is that? You're right, it's a proportional relationship, because as one part of a variable increases, the other part must increase with it, and if it decreases, the second part must decrease with it. Alright, great. Now let's talk about Avogadros. He's an Italian scientist named Amedeo Avogadros, an Italian scientist that discovered this law in 1811. Alright, so what about his apparatus? Well, simply, this is an example of his apparatus. His apparatus was a simple container that's cylindrical and has a rooftop. He used to put air particles inside, and the rooftop used to go up. And when he lets go when air escapes, when he lets the air escape, what happens is that the rooftop decreases in size. So what's happening here is that he noticed that there's a relationship between the volume and the amount of gas. So he said that as the number of gas, or as we added more particles of gas, he saw that the volume is increasing. So that's the idea that he did, or the experiment that he did, and you can do it at home. Just get a bottle and the cylindrical tubing rooftop, and don't let the air escape, of course. So it will push it slowly up when you pump air inside. Of course, there won't be pressure, because if there is pressure, then it's not correct. There should be no pressure there. Alright, so we talked about the idea. Now let's do a small example so we can apply what we understood. Let's start. So the question says, if we have 100 grams of gas, let's say oxygen, O2, takes up 48 liters. So the oxygen gas is taking up 48 liters. The pressure is staying constant, that means there's no increase of pressure. So we only have pressure and also the amount of particles. The amount of that gas is changed to fill 79 liters. How many grams are there present? So let's reread that and underline what's important. It says that if we have 100 grams of gas, of O2, so the first thing that we're saying that we started with 100 grams of oxygen, O2. and it takes up place of 48 liters. So they're saying that the 100 grams are taking up 48 liters of space. So that means we understood from that that this is the V1 and this is the N1. Alright. Pressure being constant, alright, that's a good idea, that's a good information. The amount of that gas is changed. Okay, they said that, but did they give us a number? No. So what does that mean? It means that the question will ask about the number of particles. So we underline that. Always underline what is unknown. To fill 79 liters. So that means this change filled up 79 liters. So that would be the second volume. So they're asking how many grams are there. But why are they asking how many grams? Although we started with grams. Well, simply when we talk about Avogadros' law, of course Avogadros is a scientist that he made this law and made a law called the Avogadros number, which talks about moles and the Avogadros number. I made a video about it. You can open the channel and check it out. Alright, so we're dealing here with something called moles. So, what does that mean? Well, you can go back to the video and check it out because it will be the video will be long if I just explain what is a mole. So, for people who have watched it or have a basic idea of chemistry, that means that whenever we're dealing with amount of particles in an ideal in a gas law of Avogadros, we need to always think about n, the n that is given, the variable n, as moles. Alright, so let's put down the givens. First things first, we need to understand the variables that are given. Always whenever we're dealing with amount of particles, n is the variable that's going to be used. As volume, it's going to be V. Alright, so let's plug in the givens. So they said that N1 equals to 100 grams. What about V1? Well, it's 48 liters. N2 is a given? No, it's not. So I'll put a line. V2, it's given, it's equal to 79 liters. Alright, let's start. But wait. Didn't we forget to put the formula? We did not, but I left it to the last part so we can understand how to apply it. So I would like you to imagine, we said this relationship is proportional. So how can the formula look like? Or what will it look like? You're right, it will be in the shape of a fraction. So this will equal this. Alright, what about the other things, the variables? So the variables are going to be really simple. It's going to be always N1 over V1 equals N2 over V2. Alright, that's great. So that means here that we have the number of moles up and the number of volume is down. So let's start solving. Now always, as I always tell everyone in the videos, whenever we're doing what's called formulas, we need to leave the unknown in one side of the equation and take the rest of the knowns to the other side of the equation. So we'll do that mathematically. So what is not given here is N2. We want to leave it in one side of the equation, which is the right side because it's there. So in order to do that, we have a fraction or a division here. So in order to break that, we need to multiply V2, the variable under it, in both sides. This cancels this out, and we're left with N2 in one side. Now let's rewrite the formula according to what we got. We have N2 by itself, on its own, in one part of the equation, and that will equal to V2. V2 multiplied by what? N1 over V1. That's great. So let's start solving. Now we're going to use this rearranged formula of Avogadros' law. So let's plug in the data that we've got. First things first, N2, which is the unknown. Let's cancel it here because we already got it. So V2, what is the V2? V2 is going to be 79 liters. Then we're going to multiply it by N1. But wait a minute, didn't we say the idea of moles? Do we have moles in here? N1 is 100 grams? No, we don't. So here it's going to talk about 100 grams of O2. Alright, so how can we get the number of moles? As simple as it is. So what do? Is we simply write 100 grams, if we have O2, I will put the relationship. So the relationship is every 1 mole of O2 will equal to 32 grams of O2. Why is that? Of course, some of you would think it's 16, but it's actually not. Why? Because 16 is the mass of one oxygen atom. Here we have O2, so it's 16 plus 16, 32 grams. So 32 grams per mole is the relationship, or the molar mass of O2. So to get that moles number, we're going to cancel this unit from this unit. Grams of O2 cancels grams of O2. We get 1 mole of O2 multiplied. So when we're doing now the math to get the number of moles, what are we going to get? 100 times 1. That will equal simply to 100 moles of what? Of O2. Alright, great. We got the number of moles. So this would be 100 moles of O2. Great, so let's start solving now. So we put up 100 moles of O2, 100 moles of O2, and then we take V1. What is V1? V1 is given as 48 liters. Great. Now let's cancel the units that are alike. We have liters up, liters down. Whenever we have up and down the same values, we cancel them out. So liters cancels liters out, and let's do the math right now. So to do the math, we write 79 multiplied by 100 divided by 48. The answer that we're going to get is simply N2 equals to 164.58 moles of O2. Great. We finished? No, we did not. Because the question says, to how many grams are there? So we need to find the number of grams. Now in order to convert that, it's really simple. And to do that, we're going to take 164.58 moles of O2, and let's convert it to grams of O2. So every 1 mole, now we flip the other relationship that we used, equals 32 grams of O2. So this cancels this out, we're left with moles. So 164.58 multiplied by 32 divided by 1, that will stay the same. So we'll have the final answer of 5266 or 5266.66 grams of O2. So we have grams of O2. So let's write it down. Let's put it above. If it's not shown in the camera, we'll put it up. It's going to be the N2 equaling to 5266.66 grams of O2. Great, so that's the final answer that we got, and we got everything here that we need. Alright, so let's do a quick revision and understand what's happening and what we did. Always whenever you're dealing with Avogadro's law, you should always remember that we should, whenever the given is in grams, we should always convert it to moles. After that, if the question mentions that the answer must be in grams, then you convert again the moles that you got into grams in the total answer. Second thing, the relationship between the number of moles or the amount of particles to the volume. We said as we increase the number of moles or the amount of particles that we put, what will happen is that, so N1 is the N is increasing, then the volume must increase with it. So it's a proportional relationship, and the opposite, if this is decreasing, this will decrease with it. Alright, so we have a proportional relationship. So this is all about Avogadro's law, and I hope it was useful. So you can watch other videos in the playlist of the gases, and you can go to the link of the description and you find questions, some drop quizzes about this idea. So this is all about our lesson for today, and I hope it is useful. Have a good day.